We are going to roll two six-sided fair dice. In the first part, it says we're going to let event A be the event that we roll a 4 or a 5 on the first dice, and then on the second one, we roll an even number. Now, if I roll a 4 or a 5 on the first roll, my first value, when I list them as ordered pairs, needs to be a 4 or 5. Now, the possibilities of even numbers when we roll a die is 2, 4, or 6. So I could roll a 4 and a 2, a 4 and a 4, or a 4 and a 6. So the second number in our ordered pair needs to be even. So when I roll a 5 for the first time and then an even the second time, I could have a 5 or a 2, a 5 or a 4, or a 5 or a 6. So in event A, I have a total of 6 possibilities. So the probability of A is going to be 6 out of 36, which when I reduce that, I get 1/6. There's 36 possibilities in all when I roll 2 die. Now, for part B, we have event B is that the sum of the dice is at most 5. So if I add the 2 dice, I want it to be either have a sum of 2, 3, 4, or 5. Now, when I roll the first die and I roll the second die and I add them up, that's the sum that we're talking about. So I could get a 1 and a 1 to add up to 2. I could get a 1 or a 2 to add up to 3. I could get a 1 and a 3 to add to 4, or I could get a 1 and a 4 to add to 5. Then if I look to see what my choices are, if I roll a 2 on the first try, I could get a 2 or a 1, a 2 or a 2, or a 2 or a 3. Now, I can't go higher than that because if I go out to 4 and I go 2, 4, then if I add that, that's a 6. The 2 and the 4 will give me a 6, and we want it to be a sum of at most 5. So when we go through and we find all those sums, we're going to find a total of 10 ordered pairs, which represent the 2 die that's rolled. Okay, and so in event B, we're going to have a total of 10. So when we find the probability of B, that's going to be 10 out of a possible 36. And when I reduce that, that's 5/18, which is, and you can put that in decimal format. Now, the next question says, are the events A and B mutually exclusive? Mutually exclusive means that there is no overlap. They can't happen at the same time. So when you look at event A and event B, I don't see any of my outcomes as the same value. None of my outcomes are the same. For example, if I look in event B, I have a 4 and a 1 here, but in here I don't have a 4 or 1. If I just spot check it, if I look at 3, 2 here, I don't have a 3 or a 2 here. Same thing goes this way. If I spot check it, if I look for 5 and 4, in here, I see no 5 and 4. There's no overlap. None of these are in common, which means they're mutually exclusive. There's no overlap. And another way to say that is that the probability of A and B, that would be 0. The probability of picking something that's in A and B at the same time is 0. Are they independent? In order to show that 2 events are independent, we need to show that the probability of A is the same as the probability of A given B, and also vice versa. We would also need to show that the probability of B is the same as the probability of B given A. Now, if one of those fails, then they are not independent. So in this case, I didn't have to show the second example because it failed on the first condition. So we got that the probability of A in the first part was 1/6. That's this here. The probability of A given B, because they're mutually exclusive, is going to be 0, which means these are not the same. And as soon as one of those conditions are not met, we can say that they are not independent because both of those conditions need to be true in order for them to be considered independent.